So we've got decades and decades of experience up here, probably more than the guests want me to tell. So we're going to try to get as much content out of them as we can. So I'm going to rip through the introductions, and we're just going to jump into it. Rules of the road, I'm going to ask each guest a question. Everyone can pipe in after the first go. So on my far right is Michael Harries. He's the partner of the Robotics Hub. Michael. Next to him is Scott Summit. He's the founder of Ethereal Matter. And if you've been back in the demo room, maybe you saw that big machine and took a little ride or a ski or a shoot or I don't know, you got all kind of things on there. And then to my immediate right is Andrea Kay. She's the managing director of Silicon Valley Robotics. All of them are on LinkedIn. Check it out. You guys can all figure that out. If you want to follow up with them afterwards, I guarantee send them a note on LinkedIn and they'll get back to you. So let's start with Michael. Michael Jensen at the NVIDIA show walked on stage and he had a lot of interesting things to say, but the thing that really got a lot of attention is when 7 humanoid robots marched out there with him. I know you know some of those companies. Tell us a little bit about the philosophy behind general purpose robotics versus purpose-built robotics.
All right, so I've been chucked straight into it here. We'll see how Andrew responds to my thoughts. Absolutely. So Andrew is the expert on a lot of this stuff, so I don't want to overplay. I have a little bit of a bias on this in that we were the first investors in one of those companies. So Agility Robotics is clearly by and far the best of the humanoid robots that are out there. That said, the humanoid space is really interesting. Right? There's a reason why people are getting excited about humanoid robots. And that's that they can go where people go, and that the new types of AI are letting us start to think about being able to have them do many tasks at once. Right? So this idea of general purpose robotics is not quite there yet, but all the signs are that it's really close.
I completely disagree. General purpose robots, I think we are a very long way off, but we are definitely very close to humanoid robots. And there are a lot more robots commercially rolling out in the world than most people are aware of. Robotics really is the technology of the 21st century. And it's the technology that I believe is going to have the biggest lasting impact. Gen AI, it's exciting and it's enabling, but it's robots that are physically in the world with us that are going to be capable of doing real things.
Okay, I'm actually going to disagree with the gentleman on my right and the lady on my left. To keep this interesting here. Bipedal humanoid robots can do a lot of things that people can do, but you take off the legs and they can do it a whole lot better, because if we could redesign ourselves, we'd use wheels. They're better for most applications. They're a whole lot cheaper. Now, the rule in robotics, as well as any design, is form follows finance. So if you have to have the baggage and the overhead and the burden of all of the complexity of a bipedal humanoid robot to do something, you're really going to have a very expensive machine that can't do all that much. You might end up with a Swiss Army knife robot that's kind of does a lot of things, but none of it very well. And on top of that, it'll break, it'll be big, things like that. It will come for certain applications, but I think ultimately the best robots are going to be the ones that are invisible. We don't see them. They do a function, but they are integrated into the fabric of our daily lives, not big atlases walking around among us.
I totally agree with the fact that the best robots are probably going to be the invisible ones, because that means they're products. They're products that we have accepted in our lives that are doing useful things for us. And it's a classic joke. Some of the roboticists in the audience know this one so well. The definition of a robot is something that doesn't work well in practice yet. And it's a moving definition, because the better we make the robots, the more they all fade into the background and just work.
Okay, you can see we could be going on for 6 hours, and I hope that we're not going to go for 6 hours, but we will later. Aren't you glad you didn't go to the VC talk? Next question, we're going to go to Scott. There's a lot of cool things about robotics is a combination of different types of technologies, mechanical engineering, software, AI, all these things. But there's a couple technologies that you're really incorporating, which is VR and AR. And I like augmented reality better than artificial reality. Your machine in the other room, is it a robot that you get exercise? Is it a game that you happen to get exercise? Or is it an exercise machine that just gives you better distraction than watching the news on a monitor over your head?
Exactly. Well, that actually is more of a semantic question than anything. Who here has done the ethereal robot today? Okay, a handful. Everyone else should come and do it before the day's out. It's a semantic question because a fiddle and a violin are the same instrument. The difference is in how you play it. Same thing here. You don't really need to know if it's a robot or fitness equipment or entertainment equipment. It adapts to whatever its code tells it to do and whatever application you bring to the table. Our goal was to use what VR and AR do very, very well, which is entice you and seduce you and give you stickiness and fun with what you really need, which is fitness and health and activity. And we do that by a coalescence of a number of technologies, of robotics, of sensors, of some AI, some generative modeling, and some gamification. And so it's really the convergence of those three elements that leads to what we have in the next room. So please come and give it a shot.
I think that's an excellent idea because I love ethereal matter. I love what Scott's done. And you know, you first started with talking about the blend of technologies that robotics is. And I found that's fascinating because there are very few people that can, I suppose, master all of the aspects of robotics. But it's really important that we bring in a lot of those different fields. And I know Scott has got a background in industrial design and a lot of the creative things. One of my, I suppose, passion areas is not leaving people out of the room or away from the table. We need to have everybody upskilling in robotics, not just mechanical engineers or electrical engineers or computer scientists. Robotics are going to be commonplace. We are all going to be interacting with robots. We are all going to be controlling robots. And it's not necessarily a difficult thing, but to create all of the businesses and applications that we need in robotics, we need people who understand problems in the world that need a solution. And you are the roboticists of the future.
Next question for Andra.
Hang on.
Oh, I'm sorry.
He's got to disagree with me.
So I'd also say absolutely, please do go and try out this technology. It's a really remarkable time. We have so many new hardware-based, robotics-based technologies coming through. Oh, there we go. We have so many robotics technologies coming through at the moment, hardware technologies coming through, that we're working out how to get them to the world. Right? So this is what Scott has is a really nice example of net new things that we can do with these technologies. And it's the first of its kind, but we're going to see many, many more of these coming through. So not only check out what Scott has, but please look at all of the new sorts of things that are emerging at the moment in the robotics space. It's an amazing time, particularly with this time of bringing in AI at the same time.
Thank you. Andra, one of my favorite robots is Skydio, the Skydio 2, which unfortunately they don't sell to people anymore because they've gone 100% to defense. But if you're not familiar, Skydio is a drone. It's an autonomous drone, and their number one design criteria was it should not crash. And so what that opens up is I don't actually have to fly the drone. I just have to tell it what I want it to do. Autonomy. What is autonomy? How does it fit? How is it going to change the game?
And I think let's unpack that the main thing that a drone has to do is not crash. And I believe the drone that Jeff's talking about, it was when there was this idea that we could have our own personal photographers, perhaps. You could throw a drone into the air and it could follow you and film your snowboarding run or your something else like that. And it would be seamless and easy to use. And you have to unpack it and say, well, what do I expect? Doesn't crash, keeps me in the focus, is simple to deploy, comes back when it runs out of charge. There are actually a few technical things that you need to live up to when doing this. But we can look at every single appliance in our life the same way. So I'm looking forward to a renaissance in the trades where we've moved from power tools to partially autonomous, hands-free robotics tools. So when I want to go mow the lawn, I go out there and I unleash the mower, whether it's a goat or a robot, and I just have to stand back and let it do the work and maybe pick up after it. So it's just that one step beyond the mower that I grew up using, which was completely physical and I had to push, to the next level of mowers that had power, to this level, to this level of mowers, which we know, like vacuum cleaners, is going to operate autonomously within those boundaries that we give it.
Yeah, I think I completely agree with those points. I think that the crossroads we're at now really is beyond simply the engineers and the coders. That robotics have gotten to a point where the actuation and the sophistication of motion, that's pretty good. The shortcoming is in how it connects to the human being. Because if a robot is going to interact with, for example, an elderly person in elderly care, that's a classic topic. It can't be an Atlas or an Optimus, because that will drive somebody with Alzheimer's to an early grave. It has to be understood by the designers, the anthropologists, the artists, maybe the dancers, people with a very different background that they can contribute to the equation so that they can bridge that gap between a robot and a human, because otherwise we'll end up like the VCR of the 1980s, where it could do 1,000 things, but since it was layered in such complexity, it only did one thing, which was play a tape. And that's all anyone ever figured out about those things. We're in the same boat here, is that the HCI, the human-computer interaction, that has to be resolved. And that's not going to be resolved by the same people who figured out how the actuation works.
Although, has anybody seen Toyota's Punyo robot? Or Punyo, TRI? Right. Speaking about robots for elder care, has anybody seen the movie Big Hero 6? Good, that's my favorite robot documentary. And it is a documentary in the sense that it was informed by real robotics research. Yes, Saul Griffith's work in soft robotics and inflatable robots, and the work of SRI International in swarm robotics and nanorobotics, not just SRI, but many researchers. These are the sorts of robot applications that we can see in research. And Toyota has developed an inflatable humanoid type robot that hugs. And you can imagine that hug we've seen in a couple of elder care robots, that ability to approach people safely and to interact not just with the hand, but to interact with whatever part of the body you happen to be coming in contact with. That becomes really important when we're developing robots for these sorts of purposes. So it might not be out in the real world yet, but it's no longer just on our movie screens.
So, and one other thing to add to this. So, yes, absolutely. We're going to see some amazing robots to do these very specific things. And a lot of the use cases we've seen so far have been all about, look at the Roomba, how do I simplify this thing and make it absolutely fit for purpose and as simple as possible? Now the counter there would be the phone, right? So my phone does a lot of different things. It's a general purpose device, so we can't throw out that capability of being able to say we can now cope with a device that does many, many things at the same time. But it's complicated to get there. It takes time, and it takes having the initial versions well understood and those interfaces really well understood.
Actually, just to extrapolate on that, there's something anybody getting into robotics wants to research a little bit, which is something called Moravec's law. or Moravec's paradox. And Moravec's paradox points out that the things a robot does very, very well, the 3 Ds, dirty, dangerous, and dull, and things like high precision, high speed motion repetitively, those are things people do really poorly. But the things that people do really well, like make an omelet or fold underwear, robots really have trouble with that. And those are not converging terribly fast. So we're going to see cobots, human-robot interaction, improving at a much faster rate than we'll see robotics becoming more successful as general-purpose lifestyle devices.
Okay, I can't believe you brought up the VCR. I was in the VCR business and spent more hours than you can count trying to teach people how to get beyond the flashing 12, which for you youngsters, that was cutting-edge technology back in the day. We're going to move on. Michael, next topic. You are in investing. You see a lot of startups. What are some of the tailwinds behind this robotics revolution? And I'm also curious, what's the role of governance and the government? Because if you look at their role in, say, moving EVs along with incentives, they can really move with incentives, they can move with penalties. So what are some of the tailwinds, and what are some of the roles that government can play to accelerate this?
The most obvious tailwinds are, simply the march of technology, right? So commoditization of and miniaturization of components, AI, cloud software. I mean, all of these technologies are leading to, a rapidly improving and combining to provide a new age of what we can now do with robotics. At the same time, we have some huge shifts in demographics. We have some huge geopolitical pressures, for better or worse, all of which are driving high levels of adoption. There's more and more capabilities across a really broad range, and there's growing demand for them. It's an extraordinary time to be an investor in the space. In terms of government, there's real questions that, I think we're seeing a lot of interest at the moment in the AI space, right? So how do we control the long-term future for what AI could become? And there's some real challenges in terms of what that could imply for us in the medium term, indeed right now, in terms of large language models that are being constrained potentially in the open source space.
Yeah,
I think there's the one thing I want to add to that is this is all complicated by people overgeneralizing, right? So I have something that might be humanoid shaped or something that acts like a human as a large language model, and it's really easy for us all to go, hey, it sounds like a human, therefore it must be able to do all the other things a human being can do. Therefore, we end up in exactly the same place of saying, oh my God, it's going to take over the world. And we're just not there.
Talking about tailwinds and talking about governance, Michael sketched out some of the technological tailwinds, the fact that components are incredibly affordable compared to what it was 20 years ago. And in a sense, once we've reached a particular price point level, which I believe we have, where we can build robots, and if you speak to, say, the CEO of Actronic, Jeff he talks about there being no reason why a humanoid robot should cost more than a car, because there are perhaps fewer raw materials involved in developing a humanoid robot. So if we can sell cars for X price, this is really the price point that we're looking at for humanoid robots. And we're seeing a lot of moves towards that. But you talked about, are there headwinds or tailwinds from government? And I really do want to talk a little bit about policy. The major tailwind that we have is based on the geopolitical tensions. And it means that we're starting to do a little bit more to support manufacturing locally. And robotics is an amazing technology that we're starting to largely build here in California or in nearby states. We're creating the business giants of the next 100 years. And we're not sending them off to be built in other places. Or if we are, we're nearshoring and we're looking at Canada and Mexico To me, this is the most exciting change that's happening. And this is post-pandemic, post-geopolitical tensions, where we've realized that a complex supply chain is a very fragile and delicate thing. At the same time, robotics is one of the technologies improving manufacturing. That, digital twin, and a number of other additive and subtractive technologies, which mean that we're developing more adaptable manufacturing. All of these things together mean that we're starting to spiral towards a really good place. And that is the place where we can make only what we need nearby, only when we need it. And that has incredible benefits for sustainability as well as economy. And I would support all policies towards reshoring manufacturing for robotics, making robots here as much as possible. California is the center of the world for investment in robotics, with Shanghai running second. Where do those robots get built? Well, California is the obvious choice. And I do sketch out a few of these policy issues. Sadly, when the National Robotics Initiative came to an end around 2020, what it was replaced with was a focus on AI. And what people don't realize is that AI used to be a chapter in robotics, as far as the government was concerned, for 20 years. Now, robotics is a chapter in AI, as far as the government is concerned. And yet, we need to have different policies for embodied physical AI in the world. Safety is a far greater consideration than explainability or some of the other things that we're focusing on for AI policy. So my biggest worry is that we're getting confused over what is the right policy for the right technology. And
we can go
I'm
for
happy to
hours.
talk more about that, but I know we've got some other...
We're running out of time, but we'll have follow-ups, and like I said, you can contact all these great people. Next question for Scott, product development. Used to say in software, we had the Intel people up earlier, that you could kind of see asymptotically that price of technology is approaching zero. And I used to always wonder, if networking, compute, and store were free, what would you build? You've been building your system, you said, for 5 years as the price of the components, the change of the technology, the power change. What's it like building products in 2024 when what you probably spec'd out yesterday is completely overtaken by something new tomorrow?
Yeah, what's interesting is that robotics is really a collection of a lot of different activities and technologies all converging in one. So when we are designing the robot that you see back there, the fancy parts are machined in Shenzhen. The coding is done in Lithuania and Bangalore. Our business modeling is done in Taipei, and our welding is done in Portland. So it's just like an automobile. It's a very international cooperation. I would love to stay more domestic and more local, but it's just very hard to do that on a dime. But the technology for things like VR, motion control, motor systems, especially sensors, is dropping through the floor, and the ease of use is going with that. Most importantly, though, the talent that knows how to use that is really becoming more ubiquitous. It used to be that you had to have 10 years of experience in robotics to know how to do some of this basic motion control coding. Now it's about a 16-year-old kid out of high school who's been doing FIRST robotics since they were born and knows how to speak in Arduino better than they know how to speak in English. And that really works for the next generation of innovators overall on all levels, because you have a generation now who's really been raised and weaned on some very sophisticated technologies. So give it a generation, we're going to see some very fancy stuff coming along.
So we're getting close to the end of our time. I've got hours more notes, but we're not going to get to it. But Rich Lyons was here earlier kicking it off, the new chancellor from UC Berkeley, and he talked about the mission of the school. And the net was they're working towards long-term societal benefit. So I'd like to get each of your take on what do you see as the long-term societal benefit of these advances in robotics. Try to keep it to, I guess we got like 2 minutes, about a minute or 2 minutes each. Start with you, Michael.
All right, so long-term societal benefits. We are entering an age of major demographic shift. It's really clear we need more automation in general. In terms of the AI element of that, this is part of shifting how we play, how we think, how we interact with the world. So I think there's tremendous societal benefits. And really, I don't think it goes beyond that, right? We need to be able to automate more. We need to be able to produce with less people doing the grunt work. And robotics is the way we're going to achieve it.
Scott?
Some of the tools that are coming into usability now are so profoundly versatile that they can approach challenges that have never been addressed before. My last company was a venture-backed company, and we were focused on using 3D printing to solve scoliosis. We did that very successfully. Leanne here was part of that. The rockets that you see, all these rockets going up into space, those are enabled by 3D printing of many of the rocket parts. That wasn't possible before 3D printing became sufficiently technologically involved. The robot that we're working on now, Ethereal out there, we're trying to improve public health and try to address the health crisis that has been brought on by the digital revolution. And when applied in the right direction, the technologies are very enabling. So it's really up to the innovator to point the compass in the right direction, because the tools are all there to get the world there.
Okay, you may have heard me talk about AI apocalypse versus Robotopia before. But I sat down with let's use the Sustainable Development Goals, the UN Sustainable Development Goals, and I spent a lot of time trying to work out what AI technology could bring to make changes there, and what robotics technology could bring to make changes. And I think in general, AI is where we're going to have a lot of scaling problems with less positive benefits. Whereas robotics is going to be how we develop the most benefits in terms of meeting most of those sustainable development goals. And I'm happy to dive into any of those areas at depth, but we don't really have that time. It's just, I think when we look at the technology that you want to get behind, because it's going to have a net positive impact on society, I say, not every robot is perfect, but robotics is going to offer a net positive for society. And I've been through enough technological revolutions to know that they don't always deliver on their grand promises. So I do have a high bar for saying that robotics is a net positive.
Thank you very much. If you want the cheat sheet, just sign up for Andrea's newsletter. Again, you can get that on LinkedIn. Thank you for being an attentive audience. Great hand for our panel. Thank you very much.